Hello everybody, welcome back. Today we're going to look at example 2 from 3.6. We're going to continue on with the next part. In example 2, it's asking to multiply two binomials with negative coefficients. We do the exact same thing. We have to make sure the negatives carry through with. So we're going to do the distributive property for this. I think it's important. So I'm going to show you another method through the distributive property that you may see. It's done the same way. It's basically a step we skipped in the previous video. So I don't want you to get confused by that. So we have bracket minus 2g plus 8, close your bracket, open up your bracket, 7 minus 3g, close your bracket. Again, the g is just in place of the x or the unknown. As long as they're the same, we're fine. In this particular case, they can be different, and we will come across those scenarios for sure. But right now, we'll just use the distributive property. So another way to show the distributive property is, remember, this first term, negative 2g, I'll put it in brackets. Anytime there's a negative, I'm going to put both in brackets, and this whole thing is going to multiply both terms in here. So it's going to be 7 minus 3g. So again, just another way to show the distributive property. And then we got plus 8, and that also gets multiplied by the second binomial, right? So this is just another extension. It's basically the step I skipped in the previous example. So again, this is just another approach to the distributive property. You can do it either way. Like I said, there's not a whole lot of difference. I basically skipped that step in the previous example. So the negative 2g, the first term in the first binomial, gets multiplied by both terms in the second binomial. So first it's going to be 7, and then it's going to be plus negative 2g multiplied by negative 3g, right? Okay? So basically what I skipped that first step in a previous example, but it's fine. You can do that. It's no big deal. So, and then we have the 8 multiplied by the 7 plus the 8 multiplied by the negative 3g. And I like to put everything in brackets, especially when it's negative, but I'm going to do it for both until you get a hang of it and make sure, because the negatives are so important. We need our integer rules, right, when we're doing this. All right, so now we're going to have here, we'll have negative 2g multiplied by 7, and we're going to get negative 14g. Negative 14g, multiplying these two together, and then we multiply these. Negative times a negative is a positive, so that's gone. 2 times 3 is 6, so that's going to be 6, and g times g is g squared. Oh, what happened there? Okay. And we have g squared. Oh, sorry. Six g squared. There we go. And then 8 times 7, obviously, is 56. And 8 times negative 3g is going to be negative 24g. All right. So now we're going to combine any like terms that we have. Combine any like terms. All right. And I like to write them in descending order. So I'm going to put the 6g first because it's the highest exponent. So I'm going to take the 6g and write it first. Maybe I'll get rid of that and just do it from scratch. 6 g squared. You can drop the brackets, and then it's going to be a negative 14g plus a negative 24g. So adding two negatives, keep the sign, add the numbers, so it's going to be negative 38g, and then plus 56 is your final. Okay? And that's how we use the distributive property to multiply two binomials. And in this case, the difference was the negative coefficients. Okay? Next, we have factoring by decomposition. This is extremely important. It's going to be one of the things you're going to carry with you. Decomposition is factoring after writing the middle term of a trinomial, so that x term, the bx, as a sum of two different terms, and then we break it apart. All right. So if we expand, if we were to do this, we have 3x plus 2x minus 2. So I'm just showing you that, and we have the 30x and 2x. So we're just showing the reverse here, right, of how we're going to get there. So I'm going to show how to do the opposite, right? And now we're going to actually factor this. Before we were multiplying, now we're going to actually factor a trinomial, okay, using decomposition. So here in example 3, we have a trinomial 2h squared plus 7h plus 6. So what we need to do is we need to find two numbers that add together to give you the b term. Remember, the b is in front of the x term, in this case h. So we have a 7. So two numbers multiplied together, or added together to give us 7. And multiplied together to give the product of AC, so 2 times 6. Remember before it was just 6 because the A value was 1. Now it's 2 times 6. So the product of A times C, which would be 12, which would be 2 times 6, which is equal to 12. That's our goal. Okay? This is what we call decomposition. So what are those two numbers going to be? Two numbers that are the sum of 7 and add together. So we only have a few options, right? Remember we did the chart in the previous example? So we only have three options. 1 and 12, which would give you 1 plus 12 is 13. That doesn't work. 2 and 6. So 2 times 6, which we have there, is 12. But 2 plus 6 is 8. And then 3 and 4. So those numbers are going to be 3 plus 4 equals 7. And 3 times 4 equals 12. So those are the two numbers. Okay? So what we want to do is, you notice how we took the 7 and we broke it down to 3 and 4? That's what we do with these middle terms. It's as easy as that. So this is going to be equal to, now remember the 7, h, splits apart, becomes 3h plus 4h. That's the decomposition part. And then what you do, and you can write these in either order. This can be 4 and this can be 3. It doesn't matter the order in which you write them. It's not going to make a difference. Okay? It's going to equal and then what you do is you want to split these in 2. Okay, so you want to split these into 2 and factor the GCF out of both. So we're going to factor these. So what is the same in both? They both have a 2, so it's going to be 2, and they both have an H. They both have a 2, and they both have an H. All right? And what are we left with? Well, 2h times h will give you 2h squared. And what do I factor out of the 4h to give me 2h? It would have been just 2. So it's h plus 2. Then we do the same thing with the next two terms, the 3h plus 6. So what is common in both? What is the GCF of both? The greatest common factor? It's 3. So it's going to be plus 3, leaving you with h plus, and 3 times 2 gives us 6. And we're done. Remember, both of the factors you have left, they have to be the same. If they're not the same, then you did something incorrect. So that's going to give us the two terms that were factored out, the 2h and the 3, they come together to become one of the binomials. So we're left with 2h plus 3. And then the common factor for both of these is the second factor. And again, the order doesn't matter. You could have changed the order there. It doesn't make a difference. And there's your answer. There is the factored trinomial into two binomials using decomposition. Okay, using decomposition. The book uses what's called logical reasoning, which is fine, but I like to be able to work these out and get the right answer without trying to guess, the guesswork. This takes the guesswork out of it, basically, is what I'm trying to say. Okay? Decomposition's great. It works really well. It's one of the factoring tools that we're going to use moving forward in each of our courses. Math courses moving forward. Okay? Well, instead of starting another one, there's only a few minutes left in the video time, so what we'll do in the next video, we'll return and we'll do example 3b from section 3.6, factoring polynomials of the form ax squared plus bx plus c. All right, thanks folks, and we'll see you in the next video soon.